So this question says, find the equation of a parabola with vertex 0, 0, axis of symmetry is the y-axis, and the graph contains the point 3, 1/2. So let's think about this. Here's 0, 0. Here is 3, 1/2. So there really would be two different parabolas you could draw. You could draw one like this, which I'll call a U parabola for lack of a better word, or you could draw one like that, which would be a C parabola. Well, what do we know? They're telling us the axis of symmetry is the y-axis. So if the axis of symmetry is the y-axis, that's the mirror, right? It has to look like that. So what is our format? That is an x squared equals 4py, where p is greater than 0. If I had a C parabola like this, the other possibility, that would have the x-axis would be the axis of symmetry. That would be a y squared equals 4px, where p is positive, just keeping the case in mind. So fine, I know x squared is 4py. I know the vertex is 3, 1/2. Great, so I'm not shifting anything around. So all I've got to do is I've got to solve for p. So fine, let x equal 3 and let y equal 1/2. And let's do our analysis. X squared, 3 squared, equals 4 times p times y times 1/2. 9 equals 4 times 1/2 equals 2 times p divided by 2. 9/2 equals p. So what does that give me? That gives me x squared equals 4py. X squared equals 4 times p times 9/2 times y. 4 times 9/2, I believe, is 18. So we get x squared equals 18y here. So let's take a look at the graph and see if indeed that goes through those points. So we're claiming we have a vertex at 0, 0. We are claiming we have another point, which is 3, 1/2, which is here. And I hope that the equation goes through, I hope the equation x squared equals 18y goes through those points. X squared equals 18y. And it sure does. Very nice. While we're at it, can we figure out what the focus and directrix are here? So we have x squared equals 18y. Remember, to find the focus and directrix, we need x squared equals 4py. We've already done this. I'm just doing this for emphasis. So if that's the case, then 4p is 18. P is 18/4. P is 9/2. So knowing that p is 9/2, where does that put my focus? Remember, the graph has to envelop the focus, right? So 9/2 up 9/2. So it would be here at 0, 9/2 would be the focus. And the directrix, remember the vertex is halfway between the focus and the directrix. The directrix would be at y equals -9/2. Right? And then if you want to find the points on the lattice rectum, you certainly could do that. That would be doubling 9/2. That gets me to 9. So what is that? 9/2, 9. So starting at the focus, doubling p, going over 9/2, 9. Check that 9, 9/2 the way around. 9, 9/2. We see that. So that is 9 units from the focus and 9 units, 4.5 and 4.5 from the directrix. The same thing at -9, 9/2. So a couple points on that parabola. Again, that if you connect those, that creates what we call the lattice rectum. but those are the points that are equidistant, right? All the points on the parabola have the same distance from the focus as they have from the directrix. 9 units here, 9 units here. This guy here, 9 units here, 9 units here. This guy, what was that point that we had? This point was 3, 1/2. So the distance from here to here has got to be the same thing as the distance from here to here. Now you look at that, that's a half, 1.5, 2.5, 3.5, 4.5, 5, that's 5 units away. So how about the distance from 3.5 to the focus, which is at 0, 9/2? Let's convince ourselves that that distance also, the distance from here to here, is the same as the distance from here to here. So how do I find that distance? So distance squared is x2 minus x1 squared plus y2 minus y1 squared, or as I prefer, change in x squared plus change in y squared. So 0 minus 3 squared plus 9/2 minus 1/2. Negative 3 squared is 9 plus 9/2 minus 1/2. That's 8/2, that's 4 plus 4 squared. So distance squared is 25, so that the distance is 5. So what have we just shown? We've just shown that the distance from the focus to that point is the same as the distance from that point to the directrix, which it should be, right? It should be, because all of the points on the parabola are equidistant from the focus and the directrix.